Hi guys, how are you? I hope you people are doing well. My name is Shivam Pandey and I'm your geography mentor. So, how are you, lovely people? What's going on? So, in this particular lecture, we're going to talk about the certain things which are related to the motion of the earth. So, in this lecture, we will going to talk about the motion of the earth. We will come to know about the rotation. We will come to know about the revolution. We will know about the seasonal changes and lot many things are there that we have to talk about in this particular section. So don't be get late, just join this session, okay, so that we can start this particular section. Now guys, without wasting the time, let's start this particular session. So the heading will be motions of the earth. So what would be the heading? The motions of the earth. Now guys, when we talk about the motions of the earth in initial stages, we have the two different motion of the earth. And what are those particular motion? We have the revolution, revolution, and after revolution we have the next motion, that is the rotation. We have the two different motions of the earth, revolution and the rotation. Now guys, when we talk about these particular motion, so as you people know that revolution is the original motion of the nebula. So revolution is the, it is the original motion, original motion of the nebula. Guys, when we were talking about the Big Bang theory, at that particular time, I have told you that when the primordial matter get exploded into small pieces, when there was the formation of galaxy, then we see the revolution. Now guys, revolution is due to the law of inertia. The force that is behind the revolution is the law of inertia. Okay, so it is due to, it is it is due to the, it is due to the law of inertia. Now guys, before knowing rotation, we have to talk about the revolution. So in this lecture we will stick towards the revolution only. Now guys, after this particular thing, after the revolution, when we talk about the revolution, here we have the two different scientists. And who are those? You people might be heard about, let me get this thing into the bracket. Now you people might have heard about the geographers or the scientists. The very first name is the Copernicus. So Copernicus was the very first person who has told to us that earth is revolving around the sun. Not the sun is revolving around the earth, it is the earth that is revolving around the sun. Okay, he was the very first person to tell us about this particular thing. So we have the very first person and his name was Copernicus. Okay, Copernicus. So when we talk about Copernicus, he was he was the first person to tells us that he was the first person to tells us about, to tell us, first person to tell us that it is the earth that is revolving, that is revolving around the sun. So he was the first person who told us that it was the earth that is revolving around the sun. It is not the sun that is revolving around the earth. Hi, good evening. How are you, buddy? Good evening. How are you? Okay. So Copernicus has tell us another thing. He tells us that earth moves around the sun. This theory, and he was the very first person. He was also the first person to tell us about the revolution. Remember this thing. He was the first person to tell us about the revolution. So he was the first person who tells us about the revolution, and he only tells us that earth is revolving around the sun. So this particular thing was given in its heliocentric theory. So this is the heliocentric theory of Copernicus, that earth is revolving around the sun. Okay, after this particular thing, Copernicus is the only person, remember this thing, he is the only person who introduced the term orbit. Copernicus has said that earth is revolving around the sun in a particular path, and that particular path is known as the orbit of the earth. So Copernicus is the person who introduced the term orbit. Remember this thing. This is again the important one. He introduced the term. Let me write it very clear. So he introduced the term orbit. Now guys, remember one thing, a very important thing. According to Copernicus, the orbit of the earth is circular. Remember this thing. According to him, the orbit of the earth is circular. Remember this thing. According to him, the orbit of the earth is circular. So these are the facts that were given by the Copernicus, and we have to imagine certain thing. When guys, earth's orbit is in circular way, or the orbit of the earth is in circular, so we have certain things. So when the orbit of the earth is circular, then at that particular time sun will be at the center of that particular orbit, and the distance between the earth and the sun will be equal if the orbit of the earth is circular, then only. So according to Copernicus, what is the shape of the orbit? The shape of the orbit of the earth is circular, like this. Okay, so this is according to the Copernicus. Okay, and sun is at the center, like this. Okay, and earth is revolving around the sun, like this. Okay, so this is the condition. I hope you people are getting these particular thing. So this is the motion. Now guys, it's a circle. If I say from here, this is the sun, this is the sun, and this is the earth, this is the earth. Okay, if I say, or if I take the radius, if I take the radius from the sun, then the radius will be equal. What would be the radius from here? If we have this from here, and from here, if we have R1, R2, R3 and R4. What is R? R means the radius. Then guys, remember one thing, R1 is equals to R2 is equals to R3 is equals to R4. So what are these are? These are the radius, and they are equal. So according to Copernicus, the orbit of the earth is circular and sun is at the center, due to which earth is receiving the equal amount of heat at any position, at any particular location. Earth is receiving the same amount of heat. Remember this thing. In this particular diagram, earth is receiving, let me write down this thing here, that earth is receiving equal amount of heat because sun, because the orbit of the earth is circular and sun is at the center. So remember these particular thing. This is according to Copernicus. Okay, this thing is according to the Copernicus. Now guys, now after Copernicus, a next prominent personality came into existence, and his name was Kepler. I guess you people know about Kepler. Many of you also know that Kepler is the student of Copernicus. Okay, so Kepler came into existence, and Kepler said that everything, each and everything which was told by Copernicus is right. Each and everything that he was the first person who said that earth is revolving around the sun. It is true. Kepler said yes, definitely it is true. Copernicus said earth is revolving in its orbit. Is it true? Kepler said absolutely true. I'm not denying with your statement. But Kepler has rejected a thing, and that particular thing is that according to Kepler, the orbit of the earth is not circular. It is elliptical or geoid shape. The orbit of the earth is elliptical or geoid shape. This was according to the Kepler. So what does Kepler say? So next person was the Kepler. So according to Kepler, Kepler's, he said that the orbit of the earth is elliptical. Are you getting the points, guys? If you have any doubt, just please ask me. According to him, the orbit of the earth is elliptical. It is not circular, it is elliptical. Is elliptical. Okay, this is according to the Kepler. Rest, Kepler is agree with each and every point of Copernicus, because Kepler was the student of Copernicus. So these are the things. Now guys, so how the orbit of the earth look like according to Kepler? And Kepler was right. So the orbit of the earth look like this according to the Kepler. So what is this? This is the orbit of the earth. So this is the orbit of the earth according to Kepler. Okay. And according to Kepler, remember one thing, that the sun is not at the center. According to Copernicus, sun was at the center, but according to Kepler, sun is not at the center. So where would be the sun? So according to him, sun is in the second focus. According to, so this is F1, this is F1, and this is F2. So according to Kepler, sun is at the second focus right there. So here we have the presence of sun. And guys, earth is rotating around the sun like this. Earth will be there. Here also we have the presence of earth like this. This is the earth. So earth is revolving around the sun like this direction, anti-clockwise direction. Earth is revolving around the sun. Now guys, what happened after this? After this particular thing, when we talk about this particular diagram, so if you see that, sir, all the radius are equal. R1 is equals to R2 is equals to R3 is equals to R4, because sir, this is circular orbit. This is the circular orbit of the earth. But guys, this is the elliptical orbit. So all the radius, all the distance would not be equal according to this particular direction. Arman, are you getting the points? If you have any doubt, then please ask me. Okay, so distance would not be equal. And guys, remember one thing. So distance would not be equal. There is a distance which is maximum between sun and the earth, and there is a distance which is minimum between sun and the earth. So we have the maximum distance between the sun and the earth. The maximum distance is here. Just wait. So here we have, guys, the maximum distance between sun and the earth, and this particular distance between sun and the earth is known as aphelion. Aphelion. Okay, and the minimum distance, this is the minimum distance between the sun and the earth. This is the minimum distance between the sun and the earth. And this particular minimum distance is known as perihelion. So we have two things. We have aphelion and we have the perihelion. Now guys, now. When we talk about the aphelion and perihelion, aphelion is the longest distance between sun and the earth, and it occurs on 5th of July plus minus 1 day. It occurs on 5th of July plus minus 1 day. Okay, 5th of July plus minus 1 day. And when we talk about perihelion, perihelion occurs on the 5th of January plus minus 1 day. It occurs on 5th of January plus minus 1 day. It may be 4th of January, it may be 5th of January, or it may be 6th of January. Okay. Now, after this particular thing, when we talk about the certain things, how things are going on. So, first of all, let me know that are we good about aphelion and perihelion? Aphelion is the longest distance between earth and the sun. Let me write down. Longest distance between earth and sun is the aphelion. Aphelion. Remember, this is very important one. It occurs on 5th of July plus minus 1 day. 5th of July plus minus 1 day. Remember this thing, this is important. After this, we have the minimum distance. Minimum distance between the sun and the earth. So this particular minimum distance is known as perihelion. Perihelion. Okay, this is known as the perihelion, and perihelion is on 5th of January, 5th of January plus minus 1 day. 5th of January plus minus 1 day. Why there is a maximum and a minimum distance? Sir, it is due to the orbit of the earth. What is the shape of the orbit of the earth? It is elliptical shape. The earth's orbit is in the elliptical shape. Okay. So these are the things that we people have to know about. So are we good about these things, guys? Now, let's move towards the next one. Next subtopic. So we have known about the aphelion and perihelion. Now we have to talk about the position of solar alignments. We have to talk about positions of solar alignment. Positions of solar alignments. Now guys, when we talk about the positions of solar alignment, in positions of solar alignment, what does it mean? It means when sun and the earth are in the straight line, whether it is north south direction or whether it is east west direction. Okay, so these are the things. When earth and when the earth and the sun are in straight line, when the sun and the earth are in the straight line. Now let's talk about these particular position. Okay, here we have the sun. Okay, so this is the sun at the second focus. Now when sun and earth are in north south direction, it means like this, in north south direction, then this particular position is known as equinoxes. This position when earth and sun is in the north south direction, it is the position. This is the equinox position. Now guys, in this equinox position we have to remember some dates, and the dates are like that on 21st of March earth will be here, on 21st of March earth will be here, and after 21st of March we have the 23rd of September. We have 23rd of September. Okay, so these are the things. After this we have the east west direction of the earth, like this. We have the east west direction of the. Now guys, when we talk about these east west direction of the earth and the sun, when get aligned in east west direction, then this particular position is known as solstile. Okay, so this is known as solstile position. Solstile position. Remember these dates. This is 21st of June, solstile, and this particular date is of the December, and 22nd December is the date. The date is 22nd December. Okay, so these are the position: 21st of June solstile position, 21st of March equinox position. Okay, and you people know that our earth is revolving like this. So like this, our earth is revolving. Okay, so this is the position, and you people should know about the directions also. Okay, so this is north, this is south, this is east, and this is west. So when earth sun are aligned in a straight direction, they are known as the in a north-south direction, they are known as the equinox. When they are aligned in when they are aligned in east-west direction, they are known as the solstitial position. When, write down here, write down. Okay, write down. When Earth and Sun are in north south direction, then this position is known as equinox. After this, when Earth and Sun are in east west direction, then this position is known as solstile. Solstile position. So, okay, we have the two different positions of the earth. Now, guys, now. After this particular thing, when we talk about the things, and the things are that when we talk about the seasonal changes, and you people know, if the distance between the earth and sun is varying, then the amount of heat that earth is receiving from the sun will also vary. If there will be the longest distance between the earth and sun, then there will be the lowest insulations, or the temperatures will be low. And if there is the minimum distance between the earth and the sun, then the insulations will be high and the temperature would be high. So these are the things. So if I make a statement that seasonal changes occur due to the combined impact of revolution and axial inclination, so do you people agree? And remember, this was the statement in your examination, that seasonal changes, remember this thing, remember this, and this is very important, that seasonal changes, write down in the form of note, seasonal changes are due to the combined impact of revolution and axial inclination. So seasonal changes are occurs only when axial inclination and revolution took place. So before big splat, there was minimal seasonal changes were there before big splat. But guys, after big splat, so there was a drastic seasonal changes were there. So are we good about these things? Now guys, so here if we want to write that seasonal changes is equals to revolution plus axial inclination. So this is the thing, that seasonal changes are due to the revolution and axial inclination. We should know about this thing. Now, how things are going on? We have to imagine, we have to uh, create a picture in our mind. Okay. So, before big splat, what would be the scenario? Okay. So, you have to imagine this particular thing, that before big splat, what was the scenario? Okay. In previous lecture, we had talked about the big splat also. Okay. Okay. So, if we have, you people know that axial inclination took place when big splat was happened. So before big splat, what was the case? If we take the vertical axis, vertical axis, now guys, now if we take the vertical axis, that there is no axial tiltation, the axis of the earth is like this. Okay, so here we have the north pole and here we have the south pole. Okay, and here is the equator, 0 degree equator is there. Okay, and after this particular thing, suppose here we have the sun. Okay, let me draw the sun proper way. So guys, here we have the sun, and if we take a two distance which are equal from the, which are at the equal distance from the equator, let's say we have a place A and place A dash, they both are at the equal distance from the equator. Now the insulations that is being received by A and A dash, suppose this is ray 1 and this is ray 2. If there is vertical axis, then the R1 is equals to R2. Ray 1 will equals to R2. So guys, due to this particular thing, both the places are receiving equal amount of heat from the sun. And due to this particular thing, if both the positions, both the places are receiving, A and A dash are receiving equal amount of heat from the sun, then the temperature of A will equals to the temperature of A dash. So this will be the case. Yes or not? Obviously, sir. If there is no axial inclination, our earth axis is vertical, then both the distance A and A dash will receive the equal amount of heat from the sun. Due to this, the temperature will be equal because they are at the same distance from the equator. Their distance is same. They are at the same distance from the equator. Write down. They are at the same distance from the equator. Okay, so remember this thing. This is the important one. This is the sun and this is the earth. This is earth. So it would be the case. It would be the case if the axial inclination was not be there. But this is not the case, sir. So what we have to know now, guys, we have to talk about the case that is the axial inclination. We have to take the two cases out there. Cases with axial inclination. Now, guys, case 2. We have case 2. Now, case 2 is with the axial inclination. Remember this. This is the earth. Here we have the presence of sun, and here we have the case 3. Okay, this is the case 3. Here we have case 3. Case 2 and case 3. They both have the vertical axis of the earth. Now, guys, vertical axis. In both the cases, we have the vertical axis of the earth. That is, earth is tilted at 23.5 degree. 23.5 degree. Here also we have 23.5 degree. Okay. And here we have 0 degree equator out there. Here we have 0 degree equator. Now, guys, remember one thing. And what is that particular thing, guys? Remember one thing. Let me draw this thing a bit higher. I guess it is. Now it is good. I guess it is now good to go. Okay, done. Done. Okay, now guys, if we take a two distance, if we take distance A and distance A dash, both the places, if we take a two places A and A dash, and both the places are from the equal distance from the equator, their distance is equal from the equator. If we take two places A and A dash, they both are at the equal distance from the equator. So you people know that, as you can see, which place is receiving much heat as compared to the either one. So A is receiving more heat or B is receiving more rays, R1 and R2. So you can see from this particular diagram, that the northern hemisphere, that we have this northern hemisphere and we have the southern hemisphere. Okay, this is the northern hemisphere and this is the southern. So we can easily see that northern hemisphere is towards the sun. So the distance of A is closer to the sun. So the distance that is traveled by R1 is lesser than the R2. I'm so sorry. So here we have R2. So remember, guys, R2 is greater than R1. R2 is traveling more distance than R1. If R2 is traveling the more distance, then the insulation will be low in A dash, and where insulation will be low, then obviously the temperature will be low. And if R1 is receiving more heat than R2, okay, so this thing is denoting the distance. If R1 is receiving more heat, R1 is traveling the shortest distance, then A is receiving the more heat. And if position A is receiving the more heat, then obviously the temperature at place A would be higher than the A dash. Are you getting this or not? Please let me know in the comment section. Please do let me know in the comment section. Remember, so this thing is related to distance. This thing is related to distance. Now guys, after this, position A1, position A is receiving much heat than the A dash. Heat received. So A will receive more heat as compared to the A dash. Remember this. So northern hemisphere is towards the sun and southern hemisphere is away from the sun. It is towards the sun and it is away from the sun. So due to this particular thing, northern hemisphere will experience summer and southern hemisphere will experience winters. And remember, this is solstitial position. So what is the date in solstitial position, guys? The date is of 21st of June. That this particular date is of 21st of June. And in June, we are experiencing the summer season and southern hemisphere is experiencing the winter season. Okay, so this is the point. So are we good about this thing? So what is happening? Nothing. The axial inclination is there, which is of the 23.5 degree. Due to this, we have taken the two places which are from the equal distance from equator, like place A and place A dash. When these particular places are from the equal distance from the sun, then the rays, then the insulations that are receiving by A and A dash is not equal because Earth is tilted at 23.5 degree. So that's why A is receiving much more heat. That R1 is traveling the lesser distance and R2 is traveling the higher distance. So that's why place A is receiving the higher temperature, higher insulation, because R1 is traveling the less distance, and A dash is receiving the less insulation because R2 is traveling the higher distance. That's why R2 is that's why A dash is experiencing the winter season and A is experiencing the summer season. So are we good about these things? Now, this is the 21st of June. Now let's come towards this side. When we talk about this particular side, what could be the scenario? The scenario will be just opposite. If we take two places like B and B dash. They both are at the equal distance from the equator. Remember, the sun rays, the insolations that are received by B and the insolation that is received by B is always unequal. So here we have R3 and here we have R4. R3 is traveling the maximum distance. R3 is greater than R4. This thing is denoting the distance. So the insolation that is received by B is less and the insolation that is received by B dash is high. Due to this particular thing, B will receive less heat as compared to the B dash. This thing is denoting the particular thing, that is the heat received. Okay, now according to this particular direction, northern hemisphere is away from the sun and southern hemisphere is towards the sun. So northern hemisphere will experience winter and southern hemisphere will experience summer. Summer will be there. So are we good about these things? Remember, this is very, very important for our exam point of. Remember this. This is the important one. Okay. So these are the things. So are we good about? Now guys, now. These are the things. What is the date? So this particular date is of 22nd December. So in 22nd December, we who are living in northern hemisphere, we are living in India. So India is in the northern hemisphere. We are experiencing winters in 22nd December and we are experiencing summers in 21st of June. So this is the reason. In 21st of June, northern hemisphere is towards the sun, and in 22nd of June, northern hemisphere is away from the sun. Remember these points. So are we good about these particular things? Now guys, if I want to ask you that guys, in simple words, seasonal changes begin only after the big splat. Before big splat, there was no seasonal changes. So do you people agree with this particular statement? Do you people will agree with this statement? Obviously, you have to agree with this statement. Before big splat, there was okay. So remember, before seasonal changes occurs, let me write down this. Let me write down this here. Seasonal changes occur only after the big splat. Before big splat, there was no seasonal changes. Okay, so these are the things. Remember this. This is very important for your exam point of view. Okay, these things are very, very, very important for your exam point of view. Now guys, if I want to ask that the what is the intensity of season, which hemisphere is receiving the intense season, so do you people able to answer this question, that which hemisphere is receiving the intense season? Okay, which hemisphere, which hemisphere is receiving the intense seasons? So what would be the answer? Come on. Remember guys, when southern hemisphere is experiencing the summers, then earth is closer to the sun. Remember this thing? Remember this? When its answer is when southern hemisphere is experiencing the summers, then earth is then summers, then earth is closer to the then earth is closer to the sun. And when southern hemisphere is experiencing the winters, then the earth is at the maximum distance between the earth is at the maximum distance with the sun. So in any situation, the intensity of season is always higher in southern hemisphere. Southern hemisphere will receive intense season and northern hemisphere will always receive mild season. So seasons are due to the axial inclination, but intensity of season depends upon the distance of the earth from the sun. Remember this. This is the important one. I'll explain you with diagram also. I'll explain you. Remember, seasonal changes are due to the seasonal changes are due to the axial inclination, but the intensity depends upon the distance between the earth and the sun. How? look at the diagram now. Now look towards the diagram very carefully. So this is the question that was in the mains examination, prelims examination, in SSC, in CDS, and all the examination out there. Okay, now, so what is the situation? Guys, look here. When southern hemisphere is experiencing the winter, it is 21st of June. Okay, and we know the maximum distance, between the earth and the sun. Just wait. The maximum distance between the sun and the earth is on which date? Is on the 5th of, the maximum distance is on the 5th of July. And the earth and the sun is receiving, when southern hemisphere is receiving winters, it is on 21st of July. So 21st of July is closer to the 5th of July. So when southern hemisphere is receiving winters, so it is earth and sun is at the maximum distance and southern hemisphere is away from the sun. And when southern hemisphere is receiving the summers, then the distance between the earth and sun is the minimum and southern hemisphere is closer to the sun. So that's why in both the cases is the southern hemisphere that is receiving the intense season. Okay, so are we good about these things? So guys, this is all for today. I hope you people enjoyed this lecture. Thanks a lot. Jai Hind. Thanks so much. Bye bye and Jai Hind. Thank you so much. Bye everyone. Thank you. And make sure to subscribe this channel if you are new to this particular channel. And don't forget to follow us on our social media handles, which is Instagram, Twitter, and Facebook. And make sure to download the Careerwill app. And bye bye. Enjoy your day. Thank you. Bye.